So hello, this talk is about containers, package management, and how the two can be friends. I'm Nisha Kumar. I'm an open source engineer at VMware, and I'd like to talk about how I actually got this job. A colleague of mine, 4-ish or 5 years ago, was given a task to rebuild a container image from source. So he opened up the container image to find a full Debian root file system in there along with some extra files. So he was able to reconstruct that root file system with all of the extra packages required for the application to work. And because he used the Debian machinery, he was able to get the corresponding sources. At the end of it, he said containers are the devil and a full-time engineer needs to be hired to attack this problem. And that's how my job was created. And 5 years later, I am still doing this job. So what's in a container image? If you do a Docker save and you untar the contents, you'll find a couple of JSON blobs and some tarballs. One of those JSON blobs is a manifest that has a pointer to the config and the order in which those tarballs need to be applied. Theoretically, those tarballs can contain anything, but practically, the first tarball is usually a Linux rootfs.
1 second.
And
All right. We see your Zoom screen at the moment.
oh my goodness.
Sorry.
And that's, I have no idea how to bring up my, sharing your entire screen. Okay, there we go. Let me see how I can share actually the correct screen. Screen 1, no. Screen 2, no. StreamYard, no. Oh, nice.
That's
Since I
okay.
didn't realize that I take this issue. Select window. Can I select a? Okay, fine. I'll just share StreamYard over here and see if that thing comes up. Okay, let me start over. All the
There we go.
way here. Can you see this? Okay.
Yeah. This brings
Um,
home an in-person conference. Just a little bit.
I know. Okay, I'll continue. So what developers do with that rootfs is that they treat it like a desktop machine, and they will install dependencies like for their application to work in however way they know how to do it. And this is how they have a controlled environment, like in a stable environment, for which they are guaranteed that their app will work anywhere. And Docker makes this super easy to use because all a developer needs to do is to transcribe all of those instructions to a Docker file and give that to Docker build, and Docker build will do all of the work of creating that isolated environment which developers can deploy anywhere. So they get the they get that portability as far as they know what architecture they're deploying on. They get that modularized reuse because they can reuse that rootfs for any of their applications. And basically, Docker does all of the packaging for them. But does it? So when I look at Docker images in my day-to-day job, I am looking for what exactly is installed in it, who supplied all of those tarballs, what is their intent, what licenses govern their distribution, am I able to reproduce that tarball, is it up to date, and can I get the corresponding sources? And my naive uh, thinking about this problem is, hey, if I had a package manager that would give me all of that information, I wouldn't have to look at it for every single container out there. But can a package manager really do that for me? We had a nice keynote at the beginning of this conference that talked about what exactly is a package manager. And it seems like everyone agrees they don't really know. As a person coming into this space, I just surveyed all of the package managers out there, and I came up with these 5 attributes. So there's usually a format for every package manager that contains objects and associated metadata. There's a build system that takes the source input and produces the package output. There's a schema for grouping these related packages that would form a larger application. There's some server-side aggregation system which will consume all of the packages and publishes the packages as they get updated. And then there's a client tool that consumes all of those packages and deploys it either to your local desktop or a remote system. Now, you could argue that the containers actually do all of these things, but in reality, it only has 2 of these attributes. One is that you can recognize a packaging format for this, and there are client tools that understand that and will deploy the packages on a local or remote system. As far as the build system and the server side aggregation system is concerned, that's where this talk will take us. And for schemas, for grouping these packages into larger applications, there are other talks in this conference that address that. So we're not going to address that here. Okay, let's talk about the build system. So as I said, developers will transcribe all of their instructions to a Docker file. Now, there are 2 ways a Dockerfile allows you to install software. You can either add it from the host system, or you could spin up a container and run a specific command that will install the software for you. And this command can be giant shell scripts all stuck in one line. And this is an area where not much focus is being developed on. It is almost like a build system within a bigger build system that breaks the bigger build system. So it's a it's something that we're trying very hard to figure out what to do, and we think that distro providers can actually help us with this. And one way is that if we give the distro provider our applications, then they would be able to create that specific dependency chain and create the root FS and then package it into a container. The thing is that we're asking distro providers to do a lot of things. They have to do this for every application out there, and I haven't even included every stream. Now imagine every distro provider doing this and creating all of these snowflake container images for every application out there. But this is essentially what Docker enables developers to do. Every single container image out there is a variant of a distro. Now, developers could use tools that are existing to create their own rootfs for their specific app. And a coworker of mine, Joshua Locke, and I did some experiments on these build systems to see whether it can produce a container image, and most of them more or less can. The thing is that, well, I'm a noob in this space, and Joshua has 10 years plus experience working on the Yocto project, and both of us found these tools very difficult to use. One thing I want to stress here is that the reason why Docker is so popular is because it's easy to use. And quite honestly, that is something that we would like to meld the distro provider tools and the container packaging tools together in order to create a better user experience. Now, maybe a good compromise over here is just using that system of building container images, which is using the kernel's file system snapshotter or some other file system snapshotter and actually controlling that environment. So making all of your inputs declarative, making that space hermetic, and producing these snapshot diff tarballs that represent a specific component. And you could create a dependency tree in this way. And there's some benefit here because once the dependency tree is created, then developers can reuse them. The downside of this, of course, is somebody has to sit there and create all of these dependencies. This isn't something a web developer has signed up for, and nobody really wants to go and package 100 and something npm dependencies. So that's an area where there's not much focus from either one of the communities, and the focus would it would be great if there was focus there. Let's look at the registry side of it. So most registries are OCI conformant. OCI is the Open Container Initiative that governs specifications for distribution, the container image, and the container runtime. So this is a layout of an OCI container image. The takeaway here is that a container image can be identified by the digest of the manifest, and you can associate that digest with a string. The string can be anything you want. There is no restriction on it. Further, Docker and any other like client CLI tool i- is tends to give let you push by digest. Sorry, push by tag, because the tag is human readable and the digest is not. Um, and there are some cool features that come with OCI registries. So I did mention the unique identification, and what that gives you is built-in integrity checks. There's also some nice tag to digest resolution that is built in. Authentication, like simple and better authentication, and some basic garbage collection. And the basic garbage collection is basically if a container image is not tagged, we delete it. And that has some unintended consequences. So if the tag is mutable, and if it can point to any container image digest, and the digest gets garbage collected, if there is no tag pointing to it, there is no guarantee that that particular digest will exist for any release. So this isn't what we want from our container versioning system. We want versions that are monotonically increasing, meaning that we can actually make some determinism about the development of the container image. And this bubbles up to the higher level management as well. So for example, this is an example of a Kubernetes deployment, and a Kubernetes deployment can point to any container string, and that string can be as loosey-goosey as you want it or as tight as you want it. But and I'm gonna stop here because there's other talks in this conference that talk about how to manage this, but this is essentially how versioning happens at Kubernetes deployments right now. So how can we solve for this? We certainly have a situation where there are these digests and they need to be organized in a reasonable way. So a lot of people compare Git tags to container tags. Let's see what happens if we map Git's object model um, on top of those. If you look at the Git object model, you'll see that there's a lot of different objects that are required to make sense of these blobs. And I'm not going to go into detail about the object model. I just want to show how much of work is required in order to organize these blobs. Okay, so let's map that to digest in a registry. You could create similar blobs that you can organize as a history, and you can add another object that is a tag. And there's a lot of processing required over here. Not only that, you will lose all of those built-in features in a registry, like the garbage collection and the authentication and the resolution part. So you have to go and build this all by yourself. Now you could integrate this into a registry, and that's what OCI artifacts or ORAS artifacts is proposing. So they propose a generic artifact object, which can be linked to containers and other artifact objects. So you could repurpose that object to create a history and a tag. Uh, the trouble with this is OCI's specification is a specification only. And if it adds all of this extra stuff that they require registry providers to implement, registry providers may not really implement it. And, this is understandable. This is extra work. So it's there's it seems like there is a lot of work that needs to happen as far as um, mm, getting all container packaging ideas into the registry space. Now imagine if we did solve that problem. This is what we'll get. We'll be able to get unique identification strings. We'll be able to implement reproducible builds. And what's nice about like actually having these monotonically increasing versions is that we can do some compatibility solving with version ranges. That means that Kubernetes application can you can actually have compatibilities with containers for Kubernetes applications. And some closing thoughts. Um, this is just scratching the surface of containers and container packaging. And there's a whole lot more that I haven't covered. So, for example, I haven't even touched on configuration management, and that's a whole mess in Kubernetes that it is a difficult problem to solve, and there is definitely opportunity for things like satisfiability solvers that can be applied in this space. So this is my call to action. Please reach out and help because I would expect this audience would know a lot about these topics, and that would be definitely beneficial to containers. So you can reach out to me on Twitter. I'm on all these Slack channels, and I'm also on IRC. And I want to learn. Let's collaborate. And thank you for listening.
Thank you very much. I always hoped that there was going to be a versioning of containers that was going to encapsulate, well, what they contain. Um, let's see if there are questions in the room. Maybe we have one. Someone's typing. While they're typing, I don't want to put pressure on them. So, when you're thinking about semantic versioning for containers, like what is the first thing that comes to your mind in terms of like the most important piece to capture?
Well, right away, I can identify that at least right now, tags are mutable. And so that that kind of that ability to like pin a tag to a digest and never let it change, that's usually not something that people think about when they're working with containers. And in fact, there's a whole you know um, movement called GitOps that actually encourages um, rolling tags. So you have a latest tag, and you can just, for every Git commit, you can push a container, you can deploy a container image that is specified to that tag. And so what happens is that updates becomes easier because all you need to do is pull from latest. Of course, there's a lot of assumptions that people are making about that. So they're putting a lot of faith in an external system, saying that external system will always give me the updates that I need. And this isn't really the case.
Living ahead is definitely a heady subject. We have a question from the room. What role do you think package managers should have in producing an SBOM? I ask because we're looking at it for APK3.
So this is talk about container images. Um, but I am also an SBOM person, so I can say that it would be really awesome if package managers could give you that software bill of materials. Mostly because the package managers know about the software bill of materials. They need that in order to do the dependency resolving and installing packages in order to make it work, to make your application work. So they already know this information. It would be nice if they could publish it.
I think we have time for maybe one more question. Someone was asking in the element room, shouldn't we start using timestamps instead of semantic versioning for containers?
Um, but what does that timestamp tell you? It tells you just, when that container image was pushed. It doesn't give you any idea about, the actual freshness of the container image, um, what version of the software you're using. Then it becomes hard for downstream consumers to make decisions about whether to consume that image or not. So, okay, you can say like it's the latest image, but it doesn't really tell you what features it has or what API it's following. And quite honestly, tags are not enough to capture that amount of information about a release. Mm, That
Try to see if we have room for one more question. Um, ah, does it make sense for container registries to develop distinct vocabulary for mutable versus immutable named references?
um, so I think so. And in fact, that's basically what I was advocating for. Um, of course, it means that you will have to, you know, do more work around implementing these for registries, and that's more moving parts to take care of. But that resolves a lot of problems that happen at the orchestrator level. I think we're at time.
Yes. Thank you very much for your lovely talk.
Thank you, CJ.